Be live in 3, 2, and we are live. Welcome everyone to Science Thursday. I'm Hugo Bowne-Anderson. I'm here with Holden Karau. Hey, Holden.
Hello.
And Matt Rocklin. Hey, Matt.
Hi.
I'm just making sure we are going live, and we are live. I just confirmed that.
There's those 20 seconds of terror while it's buffering.
Yeah, exactly, and it's never quite clear. I'm looking at the YouTube, and it's like, when is this going to happen? But we're very excited here today to talk about design principles of distributed systems with Dask and PySpark. Matt and I do these live streams from the Dask distributed coiled HQ, where we build scalable products for data science and machine learning. So feel free to check out coiled.io. Hit subscribe if you're interested. James has just written, "You are indeed live," which is great to hear, although he may have written that 20 seconds ago. We'd love for you all to introduce yourself in the chat. Who are you? What are you up to? Why are you interested in distributed systems? What are you doing here? Did you just stumble upon this? I'd also like to welcome Holden once again, who I'll ask to introduce herself in a second, but I'd like to welcome you to the Dask side as well.
Thanks.
So perhaps you can just give us a bit of background.
Totally, yeah.
Who you are?
So many years ago, I made a deal with the devil, and it served me very well. However, it did involve learning Java. So there were some downsides to the pact that I made. But, the occasional JVM stack trace aside, it's been pretty fun. I've worked on Spark for the better part of the last decade, which is super weird to think of how long I've worked on Spark for. But I love distributed systems. Part of it is I think functional programming is really cool. And I think distributed systems, we often, especially data distributed systems, we find that these functional programming models are really effective ways of helping people build data parallel tools. So I think it's been really cool. I think I've tricked some people into learning functional programming who maybe didn't realize they were learning functional programming at the time or necessarily ever. But as part of working on Spark for this long, I've made a lot of mistakes. And I'm always interested in learning more about other people's mistakes or successes so that I can avoid making those mistakes. And I actually also recently started learning Dask myself because, as previously mentioned, the JVM stack traces do get a little tiring as time goes on.
So we're here to talk about Dask and PySpark. As Matt has worked on Dask for so long, maybe, Matt, you can give us just a brief rundown of what Dask is.
So Hugo was asking me this, and I always defer the question. Holden, do you feel comfortable answering the "what is Dask" question?
What is Dask to you?
We get a variety of answers. I think yours might be different from most.
Well, yeah. So I think of Dask as a data parallel distributed system with interesting actor model as well. But in one of the things that I think is really interesting, that's the lens at which I view Dask. But I also notice that you have APIs exposed that really don't match that description, right? That's how I'm used to viewing the world. So those are the APIs that I've gravitated towards. But you also have other APIs that are just also distributed systems, but they're not data parallel. And I don't know how I would describe those APIs yet.
Great. Yeah. Most people who come on to this show and we ask that question, they say, "Oh yeah, Dask is a way to scale your pandas code," or they say it's a way to scale your NumPy code, or they'll say it's a way to do some higher level thing. Your answer is really interesting because you dived immediately to the lower level, technical details of what Dask is under the hood. So I'm very excited about this conversation because I think it'll be different from the conversations that we normally have in these things. I rarely get to talk to people who have dived deep in distributed systems. The people that I talk to are all the other Dask maintainers. And so I'm really excited to talk to you because you have a very different perspective. We also have run into each other many times. We have
yeah.
Our friendly. I actually can't remember the first time that I saw you. So we meet at conferences. We've been at conferences for the last, just for context, we meet to see each other a few times a year for the last half decade or so.
Yeah. Were you at PyData Seattle?
Sure, but yeah.
Okay, yeah.
But all I'm saying is we can't really remember. We were old friends, but on different sides of a technology barrier.
And you have worked together in some sense, or done something work-ish together.
There was a conference where we made the Dask Spark project, where one can launch Dask from Spark and Spark from Dask. We do not recommend using that.
Yeah. Do not use.
So I really want to jump in and hear about what it's like to learn Dask, particularly with your background. But before that, I got to ask, and I know a lot of people are interested in this. When we promoted this event, your title is former parenthetical long story princess of the covariance matrix.
Yeah. So that is indeed a long story, and I don't want to detract from the main reason that we're here, but I can give sort of the summary version. And it's around the time that I made that deal with the devil. And part of that deal involved renouncing my title, unfortunately. I was building, at the time, recommender systems, and I got lots of fun time to sort of just be the princess of the covariance matrix. Like, every day, that was what I was thinking about, like, how are these things related? What's going on? It was a lot of fun. But unfortunately, all good things eventually come to an end, especially in Silicon Valley. And I found a new job, and I had to give up my title. And I went back to that employer some years later, but they no longer let you specify your own title for legal reasons. They had found out that letting engineers write whatever they want can sometimes result in awkward things coming to light later. I think that's as much of that story as I can disclose.
I feel like I've got a touch of what I needed there. So thank you. I just wanted to say hi to a few people in the chat. We've got a comment from Marcus. Says, "Hey all, I'm a senior engineer at the New York Times. Period. Right. Dask is legit. Period." So that's cool. Gonzalo, senior software engineer from Quonsite, online from Colombia. Welcome. We love Quonsite here at Coiled. And we also have Paul. Hey, Paul Amond. Data architect at Media House, who's actually used Coiled, given us great feedback, and is a great fan of Dask. And Paul is actually interested in learning how we can use Kubeflow with Dask, if that's in scope. So that might be something we're thinking about. We don't know.
Totally. So I'm very excited for that question, because I just finished co-writing a book called Kubeflow for Machine Learning, From Lab to Production. To be fair, it does not touch Dask at all, but that should not stop you from buying several copies for this holiday season.
Second edition.
Is there a Halloween edition?
If you buy on a Halloween, it's the Halloween edition. Yeah.
That's great. Covered in cobwebs. So yeah, tell us about what motivated you to look into Dasky stuff and how it's been going.
Totally. So earlier this year, I was wondering, like, I was feeling kind of burnt out working on Spark. Like, let's be honest. I love it. I love functional programming. But when you do something for a really long time, you start to wonder, like, or at least I start to wonder, like, I've had this like really narrow focus. I think I'm missing out on some things. I really need to broaden my focus. I need to like come back up for air, see what's around. And so I started a blog. It's called scalingpythonml.com. I don't know, whatever. I should really know what it is. The blog posts take a long time because of my day job. But part of it was just like, I really wanted to go back to trying to use distributed systems to do cool things instead of just building them as sort of like an interesting project that's fun, right? Because like, I feel like there's this thing when you stop using something for long enough and you just become a developer of the thing, you lose the perspective. And I think for me, part of using Dask is to try and regain that perspective of being someone who's new to using a tool, figuring out like how to use a new distributed system, figuring out like, these are the things that are really hard for me right here. I bet these things are going to be hard for other people in other ways. Like, how would I fix this? And like, maybe I'll send PRs, maybe I'll fix things in Spark, but like just trying to regain that perspective. And the other thing is like also trying to escape the JVM. It haunts my dreams. I literally woke up in the middle of the night last night thinking that I'd misconfigured my garbage collector. And so that was a really that's a dream I don't want to have again, right?
The stuff of nightmares.
Yeah, it was not a solid dream. Like that was bullshit.
Yeah.
I don't know. Words. That was unpleasant.
Well, that's just fine.
Okay, cool. Cool.
And you've been doing this in public as well. As you said, I put a link to your blog in the chat. I'll put a link to your live streams on YouTube as well.
Totally.
But this is slightly tangential, but what's the motivation behind working in public and learning in public?
Yeah, so, God damn it. It's times like this, I wish I was better at lying, but I have a fake Russian accent whenever I try and lie. So it really doesn't work.
Interested in seeing that.
It's for the best if we don't.
Yeah.
But if you and I ever enter into a negotiation, I've already tipped my hand. So initially, this came because a while back I was a developer advocate, and I, like many humans, when presented with a system of incentives, look at that system of incentives and go, well, technically, and that's what led me to start. So we were incentivized to produce more video content back then, and that's what got me started. But that's definitely not why I've kept doing it. Like I've kept doing it because it's a lot more fun. And I think the other thing that I've always tried to bring in my talks, and even this exercise is trying to remind myself of this, is like this stuff is hard. And I think a lot of times when I talk to people, they don't see the struggle involved in like getting somewhere. Like if you look at a blog post, you just see like how to do this. You don't see that the person spent like a day trying to figure out why their cluster wasn't talking to each other, right? And so the reason why I keep doing it is like I want people to know that it's totally normal for this stuff to be hard. Like it's really fun, but it is hard.
You might be on mute, Matt.
Thanks. I'm curious how it was hard. I'm curious more about your experience with Dask and what worked well, and especially what did not work well.
Yeah. So
feel free to bring up any code at any point as well, not necessarily
actually,
now.
Yeah. Let's see here. So, okay, the first thing that I started off with is I also decided along this adventure that a really good idea, instead of learning one thing at a time, is to learn like 3 things at a time, because that's always a good plan. In retrospect, that is rarely a good plan, but all right. So I like a lot of the really hard stuff was like I decided instead of using like GKE or something like that, I was going to like build my own Kubernetes cluster from hand. And so I literally have a server rack it's behind the stuffed animals. And that was a pain in the ass. But once I actually like had a cluster up and running, the first part that I ran into that was frustrating was I built an ARM cluster because like I got a bunch of ARM machines and I'm thrifty, right? And so the problem is Dask's container images just aren't built for ARM. And so that was like sort of the first stumbling block. And then it turned out like Conda itself is not like super well set up for ARM. So I ended up using something else. And so there was just like this sort of like infrastructure-y getting Dask working well on ARM on Kubernetes thing. And that ended up like not being too much work. How do I say this? If I had known what I was doing, I don't think it would have been that hard. But because I was learning along the way and like I wasn't ever clear like what exactly is causing my problem, it took me a lot longer to figure that stuff out.
It sounds like you've replaced the JVM stack trace problem with the Python packaging problem.
Yeah.
So in my mind, like my easy answer is like, oh, Dask is pure Python. Just take some normal image that like is compilable in ARM that has Python, pip install Dask, and you're good to go.
Totally.
Maybe that's where you ended up. I'm not sure.
So I ended up at a hybrid of it because I also want to use PyArrow.
Good luck.
So it does install now.
Okay.
God damn it took a long time. But yeah, so I ended up essentially going through the packages. There are a bunch of them where I just like sent them out on the CondaForge thing, like, hey, can you please recompile this? And the feedstock bot did its job, and that's super cool. CondaForge.
CondaForge is awesome. Yeah.
So that was cool once someone showed me what to do there. And the next thing after that was, yeah, there were some of the packages where I was just like, this is, I'll just pip install this. And Dask is actually ends up being Conda installed, but there's some of the Jupyter stuff which for some reason behaves really weirdly.
I'm gonna try to take this and like make a slightly more meta point.
Yeah.
As you presented this problem, it sounded like you're saying it's hard to run Dask on ARM. And actually, like Dask itself is true built to run on ARM. It's pure Python. Anybody can run Python. It's easy to do. But along with Dask comes all of these other supporting packages.
Yeah.
You might need Arrow. You might need S3FS. You might need Boto. You might need Jupyter. And this is where I think there's a big distinction between Dask and Spark.
Yeah.
Right? Dask is like a small component of like a broad set of packages, all of which you need to sort of assemble a little bit, some assembly required.
Totally.
Spark is just this like monolith, which like you can plop it down anywhere, it runs in the JVM, it's got everything you need, and it just runs. And there's pros and cons to either side. But that's maybe it's like one of the big differences between Dask and Spark that we often see.
Yeah. And like I think actually, so you also use CloudPickle or no?
Mm-hmm. Everybody uses CloudPickle.
Right. And so one of the things which is just like made me very frustrated in the Spark land, because I work on PySpark a lot, is we have our own forked version of CloudPickle that lives inside of Spark that is shipped with, and I wish, and so the other thing is like realistically, like I'm sure whenever we forked it, like we had someone who understood CloudPickle, but like whoever that person is has long since left the project. And so now periodically people just copy the CloudPickle source code in and then like kind of screw around with it until our test suite passes and then just ship it. And
right. So this is, I think, again, an interesting question about the challenges of being a monolith and the challenges of being like a one of many packages approach. Yeah. And there's no clear solution. You ran into the problem of the ecosystem approach. And that was really painful for you. And it's painful for lots of people today.
It was. Although, to be fair, like I think if I was on x86, like the ecosystem problem like wouldn't have come up in the same way.
Because we have distributions on x86. Like Anaconda kind of solved that problem for x86, for Python.
Yeah. And I think eventually my guess is Anaconda will also solve that well enough for ARM.
Mm-hmm. Yep. There's like, I think I was running Dask on Summit, which is the world's like fastest open supercomputer.
Oh, cool.
And it's a power architecture rather than x86.
Oh yeah.
And I discovered that Anaconda does maintain, probably because of like some IBM partnership, they do maintain a power channel, and you can just conda install everything on there. And it was amazing. I can imagine the same thing happening with ARM.
Yeah. I mean, there is an ARM channel. It's just the packages are inconsistently actually built for that channel. Yeah.
So aside from packaging, I'm anxious to move on. What else do we run in? We're 20 minutes in.
I'm sorry. Okay. So, I mean, the next thing that I ran into here, actually, let me bring up, I have my notes of my things that were problems that I should have brought up beforehand. The next thing that I ran into was, and this is a very similar thing in Spark that is also, I think, a challenge, is the concept of where the scheduler, the client, and the executors are all running and what impact that has. And so in Spark, there's like, we have two different submission modes. There's client mode, and then there's the normal mode. And in client mode, I have my Python, it's running on my like desktop, or I have my JVM, it's running on my desktop, and it's connecting to a whole bunch of workers. And Dask directly, yeah. And Dask has different options beyond that. And so I started off with trying, I guess, what would have been the equivalent of client mode, because I didn't see any documentation that really told me like, hey, this isn't going to work unless your network is like configured in a very specific way, right? And so I tried it, it didn't work. And I was like, okay, well, I see that they're not able to talk to each other. This kind of makes sense. And so by they're not able to talk to each other, I mean, I tried to run it following the Kubernetes quick start guide for Dask. And then I tried to create, I tried this actually with both Helm and the other install, and they both ran into the same problem. But it's like, okay, my workers are coming up, but they're not able to talk to me.
Right. Let me try to tease out what I think you're saying.
Yeah.
So let's first do like a translation, a Rosetta Stone between Spark and Dask for a second.
Sure.
When you say Spark executor, I say Dask worker, correct?
Yeah.
Okay.
Yeah.
And when you say Spark driver,
yeah,
I say, that's complicated. There's two different things. Dask has separated the driver into two pieces.
Yeah.
There is the scheduler, which is doing all of like the scheduling work. That's like the administrative part.
Yeah.
And the scheduler is supposed to live along with the workers usually.
Yeah.
There's the client, and the client is where your like Jupyter session is, your Python session is, and that talks to the scheduler. But that separation between client and scheduler is like a strong architectural difference between Spark and Dask.
Yeah.
It opens up lots of really exciting things for us. Like I can be on my laptop and run things on the cloud, and like that all works really smoothly. I don't have to use some of the tricks that Spark has had to figure out around that.
So can I ask you a question about that actually? Because I ran into a problem when I did my setup with my client here, and my scheduler is in the cloud, right?
Mm-hmm.
When my client and the cloud scheduler disconnect, I don't see a way to like make that connection happy again. Is that like just I'm not looking in the right place?
Why did they disconnect?
I mean, they disconnected, I think, because what happened? So my laptop went into suspend, and like my networking stack got sad, essentially. And then it came back, and Python was running, but it took a while for my networking stack to like come back and be happy again.
Right. I mean, can you just make a new client and connect to the scheduler again?
So I could, but then I'd have to like, so if I made a new client, okay, so I guess the deployment that I'd been using for when I ran into this problem was not the Helm deployment. It was the, I make the client schedules a pod, that pod is the place where my scheduler is running. And so I can't reconnect to that. Like if I make a client, it's going to make a new scheduler. Like when I reran that, it made a new scheduler.
Right. So let's talk for a second about Kubernetes and Dask and the various options to deploy Kubernetes on Dask.
Totally.
Deploy Dask on Kubernetes. So there are a few options that people do today. Yeah. There is the Helm chart, which is probably like the easiest to get started with, but also like not as flexible as some other things. But it comes like a Jupyter notebook. It's like an easy thing to play with. Helm install Dask. If you're at home, it's an easy thing to do. In practice, that's like a good starting point. It rarely ends up being the like finish point for lots of people.
Yeah.
What's more common is Dask Kubernetes. We'll Dask Gateway in a second. Dask Kubernetes, which is like a more native Kubernetes thing. It's going to like scale up and down. It's going to manage pods directly, all that good stuff. Dask Kubernetes can be run either. It was developed with a bunch of people who were running Dask in Jupyter Hub on Kubernetes.
Yeah.
And so it was kind of assumed that you were going to run in the Kubernetes cluster, and that's not your case. You got a separate laptop that's not by your stuffed animals. It's on your desktop.
Yeah.
So you're not in that situation, and so the default configuration is not going to work for you.
Yeah.
What you want is Dask Kubernetes to launch a scheduler pod on the cluster.
Yeah.
With a bunch of workers around that, and then connect a local client to that thing.
Yeah, and that's what I have.
Yeah, and there's an option in Dask Kubernetes that can do that. You have to like explicitly select that option, and trip people up.
Although you have to set it at the config property on Dask before you call the from YAML. Because
I honestly, I've not kept track of the Dask Kubernetes project.
Yeah.
This is going back to the ecosystem thing. Like the Dask Kubernetes project is maintained by like a separate group of people. So I'm not going to be able to answer all your questions.
I mean, that's totally legit.
The third one I'll bring up, we'll get back to Dask Kubernetes in a second, but I want to also bring up Dask Gateway.
Yeah.
Maybe that's like the more multi-user team approach.
Okay.
And that's also a good thing to look at. People seem to be pretty happy with Dask Gateway. And that is a service that is running on Kubernetes that you can then talk to and ask it to launch things for you, and then it proxies connections back through.
Okay. And
so that's like another option.
That's legit. So Dask Gateway looks kind of like, how would I say this? So if I'm once again translating like back into the Spark land, like Dask Gateway looks a little bit like Livy in the Spark world.
Livy's kind of like, there is no, I think, equivalent for Livy in Dask because we have a scheduler client mix. We actually don't need Livy. Dask Gateway is more like Coil to Databricks. Like Dask Gateway is the open source approach to launch a bunch. It's a multi-user, multi-cluster thing. It like talks to a database or talks to Kubernetes and like manages a bunch of clusters for a bunch of users.
And so I could like theoretically like be like, hey, what's up? Can I talk to my old scheduler? Like I lost my connection. Yeah. And then the Dask Gateway.
You should try Helm install. I think it's Dask Hub, and that I think will give you a Dask Gateway setup. And
the Helm install will probably not work because of the architecture issue and the images, but I will put this in my list of things to try.
Going back to Dask Kubernetes, it sounds like you had a scheduler and workers running.
Mm-hmm.
It sounds like maybe the Dask Kubernetes thing, the thing that's managing that stuff, that might have gone disconnected from Kubernetes itself.
Yeah, and it most definitely did.
And maybe there was some policy there where those things auto shut off. I'm actually not sure.
So there's like so I don't know if this is like a normal thing, but I've observed it inside of Spark on multiple clusters as well, where essentially like every so often Kubernetes will just return a 403. And then you just try again. But if you don't try again, you are bound to run into one of these errors eventually.
Yeah. I generally don't know what's going to happen to your Dask Kubernetes issue. But I'm curious, what else can I help you with?
Yeah, I mean, so like, it's not like I want you to solve these problems for me.
No, but this is fun. People are now learning about all the Kubernetes issues. They're learning about schedulers versus clients and workers.
So actually, just a bit of a tangent, because one of the things that's like sort of over here that I'm really interested in about how Dask does it, because I remember you do it differently than I'm used to, is the local modes of Dask, right? And that is when you're running Dask without a cluster. Because inside of Spark, when you're running Spark without a cluster, we essentially decide to emulate the cluster. We emulate the world. And this has like some good things in that, like, if your code works in local mode, it's not guaranteed that it'll work on a cluster, but like it is a pretty good chance that it will work on a cluster. But like with Dask, I'm assuming you're bringing something up. So this is,
I'm just, as you keep talking, I'm just going to try to demonstrate things. So go ahead.
Yeah. So like with Dask, my understanding is that you've actually given some thought to single machine performance being reasonable. And I'm wondering if that comes at a cost of things that run on single machine being less likely to work in distributed Dask. Like, do people run into surprises there more often? Or how do you solve that?
That is a great question. So I've imported Dask. I've made a Dask array. I'm going to call it x.sum. I'm going to compute some stuff with Dask. If I were like running top at the time, we would see that like I was using all my machine. I never like made a Dask context or a Spark context like thing. I just imported Dask and went.
Yeah.
And what's actually happening here, let's see if I can find this. There is, I think, just like a thread pool sitting around.
Mm-hmm.
And so Dask can by default just run on a thread pool. So what's interesting about Dask is that we actually started not as a distributed system. We started as a single machine system first. And so That was actually really pragmatic. I think a lot of Dask users today are still just on single machines. And that's great. And so the distributed part of Dask actually came later. That is the weird thing, not the local thing. Local was default, distributed was secondary.
Yeah.
That forced us to think a little bit about separating out all of the high-level APIs, like array and data frame,
Yeah.
from like low-level task graphs and then off to the schedulers. It was like very well separated. Now, you brought up an interesting point, which is if it runs locally, do I know that it's going to run remotely? And the answer is for some things, right? So for things like Dask data frame, which is probably what you're playing with, like in principle, yeah, it should. There's nothing there that's going to be different. There are some APIs in Dask, like particularly the futures and real-time stuff, that is only accessible on the distributed scheduler. The distributed scheduler is also more sophisticated. It can you can update graphs on the fly. You can destroy things. You can be a lot more dynamic. And so it has other features. But for data frames, yeah, everything should work.
Okay.
It should be the same either way.
That's
performance will differ.
Yeah, that's sort of the point, one would hope.
What's nice though is that I think, especially for data frames, it's usually faster in a local mode than it would be with a bunch of workers on a local machine, because it's all in shared memory, because it's all just one process. We don't have to move things between processes on one machine.
Yeah. That makes sense. That makes sense. Yeah, because we have in the Spark world, because we made the distributed thing first and then decided to retrofit a local mode onto that so that we could do testing. We just serialize everything and copy memory all the time, because it's what you'd have to do. But it's yeah.
Yeah, and the equivalent in Dask is a local cluster.
Okay, so I totally can get that not great performance experience, but more realistic. If I'm trying to make something to live. Okay, cool.
Well, I thought I'd just bust in. We've got a great question from James about, and this is something we think a lot about at Coiled and in the Dask ecosystem as well. How does Spark handle managing software environments for distributed clusters?
Jars, baby.
Yeah.
Oh, really?
So I mean, yeah, Spark comes from the Java land, and so it depends on your cluster manager, unfortunately. So managing Python environments is not a thing that Spark really has any tooling around at all whatsoever. It just kind of assumes that everything is going to look the same everywhere.
Same with Dask, for what it's worth.
Yeah, but well, I mean, you have that prepare script in your Dask Docker thing, which is interesting.
Yeah, I wouldn't think of Dask Docker as being a core part of Dask.
Okay. Well, so then maybe we're not all that different here either, because Spark just says hey, what's up? Make the world look the same to me, and if it's not, it's your problem.
Yeah, I think Dask does the same. I think that there might be a cultural difference here because Scala Java developers are just used to dealing with jars. They're kind of used to distributing that kind of thing around, and it's just easier to expect it to work everywhere.
Yeah.
Because Spark is coming from the data engineering world, is coming from the more IT world, there's already a culture of doing that a bit.
Yeah.
For interactive data science folks, we're not used to that. Dask is often the first time they've used multiple machines at the same time. And so thinking I've got 2 different hard drives, they need to have the same software environment installed is not a thing that a lot of users are used to thinking about.
Yeah. So I know that, for example, Cloudera has something that runs on top of Yarn to make Conda environments everywhere appear the same. So I imagine that Dask and Spark could both use the same tools that are used in those cases. It's just the expectations are different. It's interesting.
So we've got just over 20 minutes left. And I'm enjoying a lot of things here, including finding out about your learning path in Dask. I'm loving you asking Matt all these questions, but I'm wondering if there's anything you really want to get to or really want to cover. I just wanted to flag that we have.
So like the two things that I really want to get to is your automated worker bounce at memory usage. Like I want to talk about where that came from, how you chose your limits, like the downsides of it, because I run into all kinds of issues in the Spark world with out of memory exceptions and various things like that. And this just seems like such a different solution than the one that I'm used to. So I really want to talk about that. And I also want to talk about dynamic scheduling. And then other than that, like I have an infinite list of things that we can talk about, but those are the two that if I didn't get to, I would be sad.
Great. So I'll like bring up the Dask adaptive scheduling thing. While I do that, can you talk about like what is Spark's solution like? That people, what policy do you use? Just like let's maybe communicate a little bit to the tech geeks in the audience.
Yeah.
What is Spark's policy?
So Spark has unfortunately a fairly limited dynamic scheduling policy. The concept is there's looking at a task queue. So like Dask, we have all of these tasks. They build up over time. And if the task queue remains non-empty for a long enough period of time, we just go, oh, we probably need more machines. And we start scheduling more machines up to some user-defined maximum. And this, it's not perfect, right? There's upsides and downsides of this. And then the scaling down, so I don't know. I think of dynamic scheduler as like timeshares. They're really easy to get into, but really hard to get out of, right? Like the tricky thing is once I've scaled up a bunch of nodes, how do I know which nodes are okay to remove without losing either important information or something which is going to cause me to like need to reschedule a bunch of other nodes anyways. So like that's the trick, and that's where I've been working on this for 6 years, and we're finally merging in Spark 3.1 some basic support there. So I want to know how you're doing adaptive scheduling to see what I can steal.
So just as like a general, like to like lay the groundwork, people like adaptive scaling because they don't have to think about how big the cluster should be. They can just say, give me however much is appropriate. And also, more importantly, it'll scale down and remove workers so you don't have like idle clusters running all the time. That ends up actually being more important for people we talk to. So I'm just like showing a video. If you go to adaptive scaling docs on Dask, on the right, we're seeing a list of workers. It's kind of fuzzy, but seeing a list of workers, there's 5 workers currently. You can also see that here. And then we're going to like run some computation and we'll see things change. So like with Spark, in Dask, you can provide a minimum and a maximum number of workers. And now the question is like, how many workers should we have? So we then went down to 1 because we weren't doing any work. And we'll see in this demo, it'll like explode up and then go down again. Yeah, so internally, Dask keeps track of an expected runtime of every task that is being asked to run. And so it has like a total sum, like amount of expected time things are going to take. It knows I've got 5 compute CPU days of work, and then it then also knows like the sort of the width of the task it's being asked to provide compute, and so it makes an estimate of how many cores it wants.
So how do you make your estimate? Because like we looked at that problem, we were like, oh god, this is hard. And walked away from it. So how do you do your? We
compute an exponentially weighted moving average of every task type.
Okay.
So like you can see in this one that we've got random sample and some aggregate tasks.
Yeah.
And so Dask keeps track of runtimes, memory used, lots of other stuff. And Dask actually has to do that in order to do task scheduling effectively. This is the magic of Dask. It has a ton of heuristics and it gathers a ton of information to make all of these kinds of decisions on the fly.
That is awesome.
And this is kind of getting to where I think Spark and Dask differ a little bit. Spark was like designed for data framey, SQL-y kinds of things. And so you guys really focus on performance at a higher level with like SQL query optimization, for example.
Yeah.
In Dask, we had like a more varied workload. And so we couldn't do that. Instead, we had to do all of our like intelligence at a much lower level. And so we track this thing on like on a per task basis, which gives us some advantages. We've got like, a lot of interesting information, but is also I wish I could have high level query optimization sometimes.
Yeah, I mean, because like high level query, what is it? The fastest data to process is the data you don't have to read.
Right.
But like, I wish I had this kind of information when I was trying to do like my dynamic scaling algorithms. Because right now, like, yeah, I mean, like I have an LRU cache of like, hey, how recently have certain kinds of data been accessed? But like, I don't have any idea how expensive the different kinds of data are for me to compute, or even actually, there's a whole class of data where I don't know how large it is, which is just super weird. To like have to make decisions based on like, well, I have 7 files. These files could be a kilobyte.
Yeah.
They're probably not larger than 2 gigabytes, but they also might be.
Yeah, and operating in that uncertainty ends up forcing you to construct a lot of heuristics and collect a lot of state about historical behaviors. And we're kind of making the assumption that things now kind of look like how they used to be. I'm bringing up some code here on the right. This is the scheduler file in distributed. So just quick summary, there's the Dask repository, and there's a separate repository called distributed, which has all of the scheduler logic in it. And inside of that, there's scheduler.py. We tried very hard when making Dask to be a pretty simple in our terms of our architecture. So like it should be pretty accessible to anybody who knows straight Python. It's not very sophisticated. And there's a lot of classes like client state, worker state, all the way to task prefix, which has some of the information you're looking for, and also task group. Which is also fun.
Fascinating. Yeah. Because I mean, we end up because we didn't make it a core part of Spark. Like inside of the dynamic logic, which we have been bolting on slowly over time. Like someone recently this year made something to estimate like how long the task was going to go, but like that was like this year that got added in, and that got added in. Like Spark itself doesn't really know that, but like the specific dynamic scheduler has kind of a guess of how long this task is going to go, and whether or not like it's safe, it's going to be safe to make the node exit soon, or if this node is going to like need to be a long living node.
Yeah. And again, because Dask is more general purpose, with more of a like general purpose parallel programming system, we've had to deal with that uncertainty from day one. Your next question, I forgot though. What was?
Yeah. So
I'll just
I'm really
step in
curious.
for 1 second. We've got an interesting question from Guy Maskell. So welcome back, Guy, who joined us last week as well. What single piece of advice? So this is more general. What single piece of advice would you give to someone first setting up a Dask cluster on-prem to take a first step to Dask distributed?
I would go look at the Dask setup documentation, and it depends a lot on what your on-prem cluster is. If it's Kubernetes, is it an HPC system? There's a lot of different cases. So don't have a clear answer to that. That depends a lot. I need more information to direct you properly, except other than the Dask setup documentation.
Great. Let's move on.
Cool. So the other one that I want to talk to you about is your automated bounce of workers based on the memory usage. Why was that? Was it introduced for the reason that I think it was, which is like out of memory exceptions? Or why was it introduced?
Automated bounce. You're saying like if I kill a Dask worker because it runs out of memory. Is that what you're talking about?
You restart a Dask worker when it runs out of memory, I think.
Yeah. let me briefly talk about how Dask handles memory. So Spark, you have a lot more control here than we do. You have probably a better estimate on like how many bytes you're bringing into RAM. You also have the JVM, which tells you very precisely how much everything, much more precisely than we have in Python.
Yeah. I have a fuzz factor of like 20%.
Yeah, I've got a fuzz factor of infinity. It's tricky. Especially because like Python is often like allocating things in C that aren't necessarily brought back up, or like on the GPU, like there's a whole other memory space we have to think about. And the JVM, you've got some advantages here. Dask workers. So when Dask workers memory starts going up, it'll first start spilling to disk. But like memory can keep going up, and eventually it'll just stop doing work. And then after that, when you get very close to the limit, we restart the worker. And that's your question. Why do we restart? And the answer is because a lot of Dask users are on resource management systems that have long queue times. And so they would much rather Dask kill the worker and bring it back up again than the overbearing job manager kill the worker, and then you have to resubmit a new job and wait an hour for it to arrive in the queue.
Oof, an hour.
I mean, it could be however.
Sure, but like an hour is not like out of the realm of things to be. Oh wow, that is.
Well, so a lot of Dask users are on HPC systems. Like Slurm, PBS, and a lot of the systems were actually designed for batch jobs or designed for NPI jobs, and so, like queue times of hours are not common, but modestly common.
Yeah, not unheard of. Like, how does with the Spark scheduler, like, I recently, actually last week was changing a piece of code where there was an assumption that everything would be scheduled, or like a request for resources would either be handled or failed within about 10 minutes. And if we hadn't heard back, it meant it failed, right? And that was just like, I remember being like, well, this isn't, I've run into like a few situations where like, this isn't 100% true. We need to like actually handle this better. But like,
if you're on the cloud, like a few minutes is the right amount of time to wait for a resource.
Totally.
Right? Unless there's a GPU, in which case maybe it's a little more. But 10 minutes is a reasonable amount of time if you're dealing with the like infinite resource capacity pool that is the cloud.
Yeah. That is not where I was gonna.
Where were you going? What was your mind? What were you thinking about?
I mean, I was assuming that you were bouncing the worker so that you could preserve like some of the state, or like save something that was expensive to recompute. But that does not sound like what it is. It sounds like it's because like the scheduler up above can sometimes take a while.
Yeah. Or the scheduler above can kill us is the challenge. I mean, when we do retire a worker, we do try to move the state off to other nearby workers. Like there's a lot of like intelligent trying to balance things, but we don't always have that. We don't always have that time.
Yeah, I feel so. When the what do you call the scheduler that is scheduling Dask? Because I never know what to call it.
A resource manager, maybe?
Okay, when your resource manager tells you that pods are not pod, when your resource manager tells you that Dask executors are going away, what do you do?
So usually the resource manager will do that by sending a signal. They'll send an interrupt or a kill signal.
Yeah.
And that usually gives us like a minute to clean things up. Yeah. And so we can interrupt that signal, and we've got a minute to shut down the worker. It stops doing all the work it can. It starts pushing all of its data, all of the data that it needs to send out to other workers.
Yeah.
And then it cleanly retires itself up to the scheduler. If it gets killed in the middle of that, too bad. We have to redo work.
That happens. Yeah.
But yeah, it's nice that resource managers give us some time to make that cleanup process.
So that feature is only just now landing in Spark. And when I tried to introduce it 5 years ago, people told me that that was silly and we didn't need it. And part of it was because like 5 years ago, people were largely running on Yarn, not in the cloud to the same degree. Like the world was different.
Bot instances, preemptive nodes actually make it like highly financially incentivize people to use robust, resilient systems.
Oh yeah, for sure. Because like Spark will survive, but like there's no reason to waste computation and redo it again. Like so that's really cool. How do you have any priority mechanism that you use for deciding what to migrate? Because like I just go like, hey, whatever was used most recently, let's migrate that, because that seemed like a good heuristic.
That's a good idea. Actually, I don't think we do implement that currently. What I would do is I would look at the ratio of compute time to memory.
Oh yeah, you have that information.
Yeah, we got all the information. So if you're computing a machine learning model that took an hour and produced a 10 parameter machine learning model, let's ship that out first.
Yeah.
If I've got a big data frame that took 10 seconds to load a gigabyte of data, let's wait on that one.
Yeah.
This might get more complex if you want to think about dependencies and when dependencies are not in memory. Like you might want to start aggregating the compute time going down. Yeah. I wrote a blog post a long time ago on opportunistic caching, which follows a similar question. This is probably actually my blog, back when I was writing on my blog.
I remember I actually was reading that when I was looking at Dask stuff, because I was trying to figure out how you did caching. And I think, yeah,
so like LRU turns out to not be a good choice. You want to think about compute time, number of bytes, and recency and like frequency of access. So this is implemented in the local scheduler for Dask. It actually works. It's pretty solid. We don't have an equivalent on the distributed.
Okay. If it's okay, I'm going to just like file a Dask distributed feature request.
This is hilarious. Look,
there's
an experimental feature warning.
Yeah.
In version 0.6.2, which is like 5 years ago, and we've never actually removed.
That is actually one of my questions. Because I was just like, this seems like it's not experimental, but.
Yeah, no, it's great. And there's like lots of production systems that use this, but it's only going to work on the single machine scheduler.
Yeah.
We've never actually ported this over to distributed.
Okay.
But we should.
Okay. Let me expensive to compute data during.
Yeah, also recency. Like I would also try to think about that, but do your own thing.
Oh yeah, I mean, this is just like, I'm submitting the issue so that like, we don't like have this talk and then like never remember, because I have, I don't know.
50 other things going on?
Yeah. I mean, there was a time in my life when I like hated issue trackers, and
because you're on Jira.
It's true, yeah.
Sorry if that was a sore point.
I now use a system that is worse than Jira, that we can talk about when we're not being recorded. Oh God, I actually like Jira now. Like,
we have a few more minutes left, and other than talking about Jira, is there anything else that we should cover? Question for either Holden or Hugo.
Oh yeah, totally.
So I was actually going to, in terms of speaking of not recording, we've been playing around with, after these sessions, going and chatting with everyone who's joined and wants to join us, using a service called gather.town. And I'm going to put a link there. It's kind of, Matt describes it better than I do, but it's like a 90s Nintendo emulator of some sort that allows you to video chat as well. So you walk around the space and it's proximity-based video voice activation, and it mimics the hallway track that we all know and love at conferences. Arguably the best.
It's really nice to see the people who are in the audience and chat with them. It's hard to have one meeting with 60 people in it, but Gather Town allows people to sort of naturally segment and separate into smaller groups of 5 or 6. And so it's fun to sort of walk around, see who's around, and chat with them. So it's fun. I recommend showing up.
Also, just pivoting back to Jira slightly, I'm going to put the link for GatherDown in the chat. But I pre-COVID, I had an idea for a restaurant that I wanted to, if the whole tech thing didn't work out, called Jira, where all the meals are prepared on this big board on the wall. So like a product managed restaurant. I feel like it would have done really well, but
I would never ever go to the restaurant, Hugo. I'm sorry.
no, but you definitely aren't the addressable market there.
So who is the addressable market?
I feel like by answering that question while being recorded, I'd insult many people who I don't want to.
Yeah. We'll talk later.
It would do them well in San Francisco pre-pandemic. It would be novel.
Absolutely. So I've just put the link to GatherTown in gather.town. It'd be great to see you all there. We're going to hang out there and chat for a bit. You can choose the location of where the hangout happens. I chose a castle because, harking back to Holden's former title of Princess of the Covariance Matrix, we can consider this the Covariance Matrix Castle.
Okay.
Covariance Castle.
Covariance Castle. I like that. I'd love to thank you all for joining and for engaging, for the great questions. And most of all, I'd love to thank Holden. Thank you so much.
Oh, no, thanks for hanging out. And thanks for making Dask. Like,
thanks for making
Spark. Really cool. I feel like I have to apologize for working on stuff, but thank you.
Okay.
Cool.